Hi, everyone. I came in a little bit late, and so missed the intros and didn't give mine. Who's from the Philadelphia area? Here? Okay. Anybody else? Okay. That's where I'm from. I work for Lawrence Berkeley Lab, have for 24 years, but from my home right outside of Philadelphia. And they let me come out here in terms of my like restraining order with the laboratory twice per year for a few days, and so that's why I'm here, and I'm thrilled to be here. Anyway, I'm going to talk about a project actually on which both Jordan and Janie and another guy we've collaborated. This is a 3-year project, and the goal of this project is to try to, in commercial real estate buildings, achieve fairly deep savings, and by that I mean at least like 20% per intervention, and I'll explain that, and sort of make that business as usual. Okay, so that's our goal. You've heard from some of these other presentations. There's a ton of research. Let me see if I know how to do this. No, I don't. Oh yeah. I'm good. Yeah, thanks. So, okay, we need deep energy savings, and I think I don't need to explain to most of you why that is. When we talk about deep energy savings at the lab, and we've researched this and really gotten into this over the last couple decades, what we've realized is that to get really deep energy savings, you need to have what we call integrated approaches. So what do I mean by integrated? Integrated approaches are ones that, sort of simply put, that basically consider all the systems in the building, okay, and their interactions. Okay, that's what I mean when I say, that's what we mean when we say integrated systems. Okay, we can do this stuff, and you've heard about some of the great research at LBL. You know, we know how to cut energy use in buildings using these integrated approaches, right? We can do it really, really well. So most of my work is for the federal government, for federal government buildings, where the federal government does a ton of, about $1 billion a year of performance contracting, and when we do those projects right, we get 40 to 60% savings in existing buildings. So really quite impressive, and these are ESCOs doing the job, so this stuff all has to sort of, you know, it has to pay for itself. Okay, so we know how to do this, but the problem in doing retrofits is that they're disruptive, right? And we say they're not aligned with the real estate life cycle. What do I mean when I say that? I'll explain. But one thing is, you know, on the big performance contracts I work on, there's often 2 years to award the project, a couple years of construction. I mean, really, really long cycle time. So this is disruption, right? And it requires a lot of engineering, right? So we can do this. We can go into buildings and make them a whole lot better, including with some of the technologies you've heard about today and will continue to hear about. But it's like, it's a big intervention, right? It's disruptive, again. Some other negatives, okay, the significant engineering. Also, the utility incentives, often that's cumbersome if you're doing a very integrated project with a lot of different systems. The incentives that you're applying for are usually what are called custom incentives, and those are like a little hard to get. You got to do some M&V, and they'll pay you a little up front and a little more, and then the program runs out of money. It's a little bit messy. And then there's still sometimes, you know, if you do a project like this, well, you know, are the savings, or if you do any project, are the savings really going to materialize and persist? Those are issues. And, you know, we've talked about, this commissioning exercise. This building might, you know, this room might have been just fine 5 years ago, but there's a persistence problem, right? There's overriding, there's things falling out of calibration and so on. Okay. So all this stuff, yeah, hinders scale adoption. And if you think about commercial real estate buildings, you don't have too much opportunity to get in. You don't have, months and years to get in and do all this engineering, and you can't make all this disruption. So what we've tried to do to sort of counter that is create what we're calling integrated, and I define that, integrated systems packages, so packages of energy efficiency measures that together would provide 20% savings or more, and that could go in a sort of streamlined fashion into commercial real estate buildings. What the goal is to try to get them into these what we call real estate life cycle events. So what do I mean when I say real estate life cycle event? When would efficiency be, when could you install efficiency in a commercial real estate building? What's the juncture at which you might, what are some of the junctures at which you might be able to get this stuff installed?
20-year lifespan of the equipment.
Okay, so 20-year lifespan on the equipment. So equipment dies, right? So that's an opportunity. What are other? Yes, definitely. What are other opportunities? Between leases, you've got a new tenant coming in. Perfect. Or you're doing a new fit out for even an existing tenant. Maybe. What else? A major renovation of the space. Yeah, exactly. What's that? Yeah, potentially. I could see that. I didn't have that one in mind, but yeah. So there's something that you have to do to buildings. So you've got to make some intervention. So you've got a disruption already, and so you can sort of take advantage of that. The other, excuse me, the main one that I was looking for is just the sale or purchase of the building, right? So the building changes hands. Okay. So those are what we're calling these real estate life cycle events. Okay, so here they are, purchase and sale, renovation, the tenant fit out, equipment replacement. Oh, another one I forgot to mention, refinancing of the building. Okay, and that's sometimes a little underappreciated. So the idea is we're designing, it's a 3-year project, we're designing these packages to go in at various points. So to get to the equipment replacement, let's say the HVAC unit serving this, let's say it's a DX unit, direct expansion unit, and it dies, and we've got to replace it. So what we tried to do is sort of create a package of efficiency measures that would go in conjunction with the RTU, and we make the RTU efficient, but some other things in conjunction with it. So that's one package. We're creating, I think, 3 of them all told. Another one is at tenant fit out. And so that one would be focused primarily on lighting and plug loads, a little bit on VAV. There's another one that we haven't worked on too much where it would be like in a whole building renovation. So the idea, again, is create these packages. We're going to test them. And the idea is not just that they're good at providing savings, but that they can go in a replicable manner and in a quick manner, right? So that these can be palatable when these events occur, right? So the process of the project is we're going to develop these integrated system packages. We're going to conduct testing on site. I think a few of the speakers have alluded to our FlexLab, which sits at a building where we work about 10 minutes walk from here. We're going to sort of kick the tires on these packages, and then ultimately we're going to conduct field evaluation. And so we partnered with CB Richard Ellis, or I guess they just call themselves CBRE now, but they're our sort of demonstration partner. So once we feel like we've validated that these things save and that they can go in smoothly, and we have sort of the instructions to to make the installations happen, then CBRE has sort of volunteered to, test these things, in the field. And then, we're talking about three of the packages, and then, so once they test them, then if everything's good there, then the idea would then be to, promote them and get these out to utility programs, to building owners, designers, service providers, investors, lenders, et cetera. That's the idea. And we're about halfway through. So what we're doing now is primarily in the conduct FlexLab testing. And Jordan is going to talk about that a little bit more. So how we started this project and what I really had a lot of involvement in and with Janie is interviewing players in the commercial real estate industry. So who were those players? We called, like, Janie, how many interviews did we do? It was like three dozen or 40 or something. It was a ton of them. So we called these people up: owners, operators, tenants, investors, developers, architect, engineers, et cetera, lawyers. We talked to a ton of people. We've got some of their logos here. Some of them we couldn't even, they wouldn't permit us to put their logos here. But we talked to a ton of different people in this field, and I felt like we really got a good feel for it. You sort of know you're getting you're getting the answers when I think the latter calls sort of got a little bit boring because we started hearing the same stuff again, and that was good, and from different parties. So this was the part in which I had a real heavy hand. Okay, so from those interviews, we got really 7 sort of key themes came out. One of them is totally unsurprising, is that in the commercial real estate world, payback matters. No surprise there. So the people told us that the paybacks in their organizations were between like 6 months and 10 years. That was sort of the requirement. But we let them talk. We always gave them rope to hang themselves, and they did. They'd said, well, payback matters, but then they'd go on and they'd start talking about, well, except. And there were a lot of those excepts, okay? So, for instance, if there's if it's an owned building and there's an equipment, the chiller dies, we might be willing to tolerate more. Non-energy benefits, a lot of them, that's a term we use a lot around here. A lot of them talked about non-energy benefits. Look, we're trying to lure employees in here, and we want some sort of, sex appeal in the space, okay? So there we're willing to, be a little bit more flexible on payback. What some of the other themes we heard? It was really quite interesting. It was sort of but. If there's a refresh of some owned space, definitely more flexible there. What other kinds of non-energy benefits? Something as simple as glare was a problem in the space, so we stopped. We let the payback threshold that we normally have for energy measures completely fall out because we really cared about the glare. So we put in the advanced shades and so on. So it's very interesting what we heard on payback. Another thing is, once late in the interviews, we would mention what we were trying to do, and they loved it. They all said, yes, if you can package this stuff and standardize it and give us the confidence that these things are replicable and that they will save, that would be a big asset to us, and that would make it much more palatable for us to put this stuff in. De-risking, think of it that way. This is pretty intuitive. Get in the specs, okay? So specs I'm using very, very broadly to mean everything. Templates, one of the real estate firms has this procurement portal that they use, and so they said, if it's not in there, it won't happen. if it's in there, it will. So when we look up, RTU replacement, your package has got to be sitting right there where we look that up, because that's how we do it. Okay, their design standards, some of the things you would expect, of course, but even broader. Timing is critical. Okay, so we think about the construction, think about the installation of these things. They have to be able to go in quickly. I think that's pretty intuitive. We weren't surprised to hear that at all. But what was much more interesting was, Janie, I don't know if you were on this call. I mean, one guy, and this was sort of representative, said, look, they were in New York, and they said, look, we're working with NYSERDA that gives out a lot of incentives there. And NYSERDA sort of missing the boat on these jobs because there's a 3 or 4 week period, forget the installation, where that decision is made about what's going in. And if you miss that boat, you're out. So that was really interesting. So it was not only the installation time, but the when that decision happens in the process. This is pretty intuitive. Lease and ownership structure really, and the term really matter, okay? And you might think, yeah, okay, if it's a gross rent, then the owner's going to care about the efficiency. If it's a net lease, then then the tenant will more. But it's even deeper than that, and you really sort of need to follow the money. So it might be a triple net lease on the facility, and you might think, well, okay, so the tenant might be motivated on the energy side. But if they're paying their energy bills in sort of, these, what do you call them, CAM charges, they're basically paying per their area, such that any gain they had would be divided among all the tenants in the building. They might be significantly less motivated. So you really had to see, for any savings, who's going to be the beneficiary and how's that going to be split up. Okay. So that was interesting, and the term. Some of these real estate investment trusts and other investors, they have a very short time frame. So they're, Janie, what was the term they used? There were the value investors and I think it's the value investors are sort of in for the longer term. I forget the terminology, but there's others who are just buying it, and they know damn well when they buy that building, they are buying it to hold it for 7 to 8 years. Okay, and so they're making all those decisions about their changes right up front, and naturally the thing better pay back within 7 or 8 years, probably south of that. But that was pretty interesting, a little bit eye-opening for us. Yeah.
And there were people who were doing these things because they needed to have energy efficiency in order to attract people to businesses.
Yeah.
So it's different kinds of investments.
But the buy-in holders versus the get-in, get-out, let's take this, what do you call it, grade B space and make it into grade A space and then sell the thing. And that's the model for some of these investors. Others are in it for the long haul, and some to occupy and some not. Right? So it is interesting. And then the last two, I would just say, the last two themes are basically just to say it's tricky. It's hard to influence because there's not just one person. You can't just, like, if we just convince the coach, then it's not that simple. The coach is different in different organizations because of their structure and because of personalities, right? So sort of the influence process is tricky. So it was interesting doing these interviews. I really enjoyed it. Anyway, so what we're coming out with, again, is these 3 integrated system packages that, with the idea that they would go in at like a tenant fit out, an RTU replacement, or like a whole building renovation. So three packages is what we're designing, and we're about 1.5 way through those, and starting to test the tenant fit out one, which is what Jordan is going to talk about. I just want to leave you with this one thing. So laboratory and field validation results. We're testing energy performance. We're testing for cost benefit, so to make sure that payback is down in an acceptable region, and that we're promoting some of these non-energy benefits and other things that help people get over the hump. And then we're very focused on the transaction costs, how to get this stuff in quickly and simply. And then I guess the last thing I want to say is we're not just going to throw these packages out to people, but with them, applicability guides, benefit cost calculators, design and installation specs, functional test protocols, maintenance guidelines. So we're going to try to give them the tools to make it very simple to go in. And so we're building all that stuff as well. And, it'll be very interesting to see how that's received by our demonstration partner, CBRE. So with that, I think I'll hand it over to Jordan, who's going to talk a little bit about how we actually do the testing. But yeah. Pardon me. No, Mike? If you want to say the question, and then I'll repeat it, if I understand it.
The trade-off between occupant comfort and productivity versus energy savings, how did that play out?
Yeah, so that was another non-energy benefit that was talked about. Not so much the productivity, but the comfort. And we know, there's some studies out there that draw some sort of interesting connections between those two. But a number of the firms talked about wanting to draw and retain employees and how important that was. So this was another thing that they started to say when they said, 3 to 5 year payback, and this is the kind of thing that they brought up. Yeah.
Lunchtime, I heard a discussion back here about the triple pane windows. And it was not about return on investment, like, if I get these windows, I'm going to save this much in my energy bill, and so I can afford to pay this much. It was all about the initial purchase price of the windows. And so sometimes the return on investment goes by the wayside if the initial purchase price is too much. But with these packages, it helps bring the whole thing to that gives you another measure that happens other than return on investment is, can the package price give you an economy of the fact that they're all working together and that the package has been tested out?
Yeah, good point.
Yeah, I just wanted to add that I had a situation happen years ago where I went in a leased facility for the state. There was some pretty low-hanging fruit lighting renovation and a warehouse type issue. And since the owner wasn't paying the utilities, I thought he would be completely disinterested, but he was very anxious to get the job done. What I found out later was the lease was due to expire in 6 months, and he knew it was going to make his property more valuable to be relet. He never let on that. So sometimes
asset value, I didn't mention that. Absolutely. That's another theme we heard, and they were willing to bend on the payback stuff, and yet there was a zero payback, but it was going to increase asset value. And so, that was another theme we heard. Yeah.
jump right on it.
Yeah. It was very interesting, these interviews. We learned a lot, and they've informed the sort of design of these packages. We've coupled with a very good engineering firm that's helping us design these things, and so all this stuff we've plugged into the people who are designing the packages. We've inculcated them with everything we learned from the interviews. Yeah. Was there another question?
Any other questions on the development of these packages?
Okay. Should I turn it over to Jordan?
Sure. Yeah, and maybe at the end of my bit of this conversation, if we have questions that relate to either of our topics or both, we can kind of take those. Okay, yeah, do that, then come back. And Janie, feel free to let me know if we're running low on time. I don't want to go over too much. But so Phil gave a nice kind of 30,000-foot view of this project, the Integrated Systems Packages project. I'm really going to drill down into like the ground level view in terms of development of one of these packages, and then the validation in the lab, so the FlexLab facility that you all have heard about. Has anybody here visited FlexLab? Yeah, right. Okay, cool. So several of you know what it is. That's great, because I'll be talking about that a lot. I'll try not to get too in the weeds. I mean, I'm basically on the kind of the boots on the ground doing the research in the space. So I'm really, in there with the sensors and the technology and things like that. Not always at that higher level of kind of how this fits in, but yeah. So if I'm bogging down in details, forgive me, and you can kind of give me a slap on the back. The ISP design process over on the side of the slide kind of talks about the flow of how we decided what efficiency measures belonged in a package. And again, specifically where this project is at right now, we're doing the tenant fit out version. So that's the real estate event where we're developing and validating a set of efficiency measures to be one of these packages. So we have core measures and then optional measures, and you can see those with this little dot paradigm. So LED fixtures with advanced controls is just, that's like a core measure in this package. Network lighting controls is a plus. We use the lighting controls, as I'll show in a little bit, to actually provide information to the HVAC system to help it operate more smartly in terms of demand controlled ventilation based on occupancy, which nowadays LED fixtures with sensors are capable of providing that to the HVAC system. Who's familiar with ASHRAE Guideline 36? Yeah, so that's been a big part of this. This is kind of a core part of this package is implementing the, I don't think I'll get the title of it right, but it's the HVAC optimized sequences of operations, essentially, right, for efficiency and comfort. So a couple more of the optional measures. Ceiling fans with a 4-degree setback. So if the building isn't cooling for long enough, we can actually turn ceiling fans on, use the air movement across bodies to reduce our cooling energy usage by increasing the cooling set point by 4 degrees Fahrenheit in this case. Automated interior shades, that's a thing that's expensive, but if the project implementer has the appetite for it, that's an option that that we're considering and testing. Same with plug load controls, smaller scale energy savings, but just to make the package that much smarter. And then metering and performance monitoring across the board is important to us. So the FlexLab facility, here's a picture of it. Yeah, it's in front of Building 90 on the other side of campus. We just celebrated our 5-year anniversary, right? So we've been doing research projects on, I want to say something like 70 different technologies over the course of those 5 years. $36 million of research has gone through FlexLab in that time frame. So really, it's been an important facility, and it's kind of like the Ferrari in front of our offices that we use to kind of demonstrate new technologies. Marianne mentioned it, but everything in FlexLab is measured. So in the slab and in the walls and in the ceiling, we have thermistors. We've got luminance sensors everywhere, daylight glare probability packages that measure glare from the windows. On the hydronic side, the chilled water and hot water temperature change in the space so we can characterize HVAC loads. So everything's measured. All of the facilities are side-by-side test cells of exactly the same dimensions, so we can run kind of a base case and then a test case in parallel in real time and see how energy usage and air quality, if that's part of it, or other comfort parameters vary between base case and retrofit. So flexlab.lbl.gov, that's a little plug for where you can learn more about that. So again, I'm on like the test design and implementation side of things. So we basically look at what we're trying to test, this ISP tenant fit out package with the lighting options I talked about. So LEDs with advanced controls and networking, all the things that are in ASHRAE Guideline 36. demand control ventilation based on the lighting system, and then these plug load controls. So that's what we're testing. How are we going to test it? In those parallel test cells like I talked about. So we'll take an existing building baseline. In our case, it was like 3 lamp T8 troffers was the lighting system in the base case. So it's kind of a standard 1980s vintage building, and then compare that to the LEDs. So we'll do that kind of thing, come up with a representative baseline that we can expect people in the field to have in their buildings, so that when we characterize savings and performance, we do it against something realistic. We do the testing at different seasons to see how the results change with solar angle, weather conditions, temperature differences, and we'll test different configurations I'll get into in a little bit. And again, it's important that we're looking at energy and performance, right? Like somebody said earlier, you can just turn lights off in a building if you want to save energy, but no one's really going to like working in a space like that. It's, we need to keep spaces comfortable and then see kind of how the energy chips fall. So the test design process, we start with kind of a furniture and a lighting design. So we came up with this open office plan. You can see where our ceiling fans are, the diffusers. Those blue rectangles are where the light fixtures will go. The 6 desks are the 6 occupants. And then this is a rendering in a photometric software to help us dial in on the lighting packages that would work to get our required illuminance levels. So keep that in mind, and we'll see how it looked in real life when it was actually installed. So this isn't actually an occupied space. It's a laboratory environment, so we have to simulate occupancy. So we came up with 6 unique occupancy profiles, the coming and going of these simulated people. It sums to this kind of profile that you see here for occupancy through the course of the day. And we run it in this kind of what we call a Groundhog Day scenario, every day the exact same occupancy pattern. We don't want that to be a variable. We already have enough variables, so we kind of hold that constant and test against it. So to pull this off in the space, since we don't have real occupants, we had to build these little heat wands that basically trigger passive infrared detectors, which that was kind of a fun, unique challenge for us. Normally human bodies would do this for you, but without them you need a heat source that moves across the field of view of the detector. So after we came up with our fancy engineered solution, we found that those broke too often, and we went to the good old-fashioned oscillating fan model, which worked better for us. So yeah, we're nimble on our feet. Then we come up with a schedule where we kind of block off days to test each of the different configurations or permutations. So we're testing with like south facade windows, west facade, and then we're doing an interior test where we block off the window wall with polyiso foam and just do kind of what would look like an interior zone in a building to compare energy performance. So there's kind of practicalities of setting one of these tests up. So now you can see the rendering, as intended, and then how the system looked as installed. And I think, I've highlighted, a couple of the systems. So these are our fancy LED fixtures with sensors that do daylighting, occupancy sensing, and then provide that information to our HVAC system. We have illuminance sensors all throughout the space, so we're monitoring that in real time. There's the ceiling fans with the cooling setback option, automated roller shades. That's another one of the optional features. So those block glare but allow daylight in, and they kind of do that in an automated fashion. So I guess I should step back and say we weren't intending to invent new things with this project. We're coming up with a package of off-the-shelf technologies. So these automated shades, they're off the shelf. You put them in, tell them where you're located and the different parameters of your building, and they do their work based on their solar model. And then there's some occupant overrides. We do have really nice views, so maybe the occupants would accept a little bit of glare to see the Golden Gate Bridge. So they do have those kind of features. We have occupant thermal generators, so those mannequins have heat tape around them that basically emit the heat signature similar to a human body, and an ASHRAE-defined standard human body, that is. Roughly 100 watts of heat, if I had to guess. And then there's those occupancy sensor triggers. We have these high dynamic range cameras that do daylight glare probability analysis. I'll show some images from those in a minute. And then the plug loads, they provide internal heat that needs to be managed by the HVAC system. And we also are controlling those with that option, the optional feature in the package that does some plug load control. So I'll just cut straight to the funnest part of the reconfigurations, which, let me see if I can make this work. I have a couple videos in here. Okay, so this is my favorite one, going from south to west. We're probably the only energy efficiency facility in the world that does it this way. Right, and this was yesterday morning. We went from a south configuration to west configuration, so we have the entire lab is on a lazy Susan that can rotate something like 300 degrees or so. So we can face from north to south to west and kind of really characterize things like daylight performance with those different, and then the other reconfigurations I talked about, interior versus perimeter, and then core versus the core plus options. Okay, and then I wanted to show what a day in the life of this experiment looks like. And this actually is imagery from the HDR cameras. So you see that false luminance map there kind of pinpoints areas of high luminous intensity and calculates glare, which you can see in the corner here. So that's not bad for glare, right? But let's see this. So this stitches together the HDR imagery for a day. So you can see the lights coming on and off as occupants come and go. The shades are going down when the sun angle requires it. I think in the afternoon we'll see when we've been in cooling long enough, the fans should kick on. So let's see if that happens. Yep, so the fans turn on for a little while. Right, so that gives just a picture of what happens in that space. And this is all automated. It's basically a symphony of a bunch of sort of unique measures and subsystems working together in this integrated way. And our intention is that the whole is greater than the sum of the parts, right? So we're measuring this to see if that's in fact the case, but we're targeting that 20+% whole building energy savings, and we're measuring everything in here to see kind of where we fall. So let's see how we advance to the next slide. Okay, so yeah, I just wanted to show some of the measurements that we have taken in the space. This project is ongoing, this particular FlexLab experiment. So these are measurements from August, but you could equally go and look at this from today. So we have light levels in the reference cell and the test cell. Our target level is around 500 lux at the task plane, and you can see how we meet and exceed that in both cases. So with the LEDs, we have a lower overall average illuminance, but still within our target range. Lighting power is really the biggest impact from this package. So these are stacked graphs. So the topmost one represents the sum of all the lighting wattage in the space. So we're almost up at 600 watts for the entire facility in the reference cell, and like much lower in the test cell. And it's dynamic throughout the day in the test cell, because as occupants come and go, the fixtures turn on and off, or at least they dim, and then they dim further with daylight harvesting. So earlier I showed this occupancy pattern that we had come up with before the test, and then we needed to implement it with our little fancy hand-wavy occupant triggers, right? And you can see actual occupancy in the space tracked our intention pretty closely. And again, this information is fed to our HVAC system, which does demand-controlled ventilation based on how occupied the space is, so that we're not having to condition air unnecessarily when fewer people are in the space. So we expect to see good savings there, but we haven't analyzed that data yet. Here's some of the trending of the HVAC set points and the cooling energy for a few days in November. So just to point out, we have outside air trended, and then the internal temperature in the two cells mostly stays within that the heating and cooling deadband, and it does so by we're in a cooling season here in November. Yeah, I mean, Bay Area weather is a little bit strange if you're not around here often. Sometimes our warmest months are in October, November, and then really our coldest ones are in like June and July. So I'm from the East Coast. This baffled me for the longest time. But anyways, you can see a huge difference in the cooling energy in the reference cell and the test cell. The test cell is the blue plot. So with that reduced lighting wattage and so forth, we're not needing to do nearly as much cooling in that space. So then, this is a look at lighting energy savings for a few different seasons of testing. And I kind of showed this with the previous plot that trended kind of our lighting power, but the watts per square foot in the test cell is significantly lower than the reference cell and averages out around 80% savings. So the whole idea with that day-to-day data collection is to come up at the end of this with, a validated savings paradigm that we can apply to a variety of buildings out there in the real world to help, as Phil mentioned, de-risk this process for participants. They want to know that this package, at least within some certainty, is going to save energy, and hopefully, know how much energy so that they can start to look at the payback and decide whether it's worth it. So this is an example of an annualized model from a previous project that did FlexLab testing. So we do kind of like a regression analysis where we look at savings for each day and then compare that to parameters like weather conditions, solar angle, things like that. You do a multivariate regression analysis to say, okay, for your particular location with your annualized weather data, this is the energy savings we expect for your location. So this is where we want to get with this project. We're not there yet because we're still in this testing phase. So there we go. That's again the in the weeds details. So I guess, do we have time for questions either on like the specifics of FlexLab testing or more generally on the ISP project? And
So,
okay.
Phil, do you want to go on up there in case there's questions for
So
you?
yeah, give Phil the hard questions and
So
me
do
the
we
easy
have any questions
That's
on how the testing, I think many of you are familiar with FlexLab because you've been in there, but now you see how it's actually used and how it's instrumented. I think you saw those, the dummies, the pictures that they showed there, how they're thermal wrapped so that they simulate people. And perhaps you have some questions about how the testing is done. Larry? I'll come up there with the microphone.
Here, I can, for folks in the front of the room, you can just use this mic.
Sure. Yeah, regarding your partners in this pilot, in particular CBRE, is this work being done nationally? Roughly how many pilot projects are there?
So they're in our, what do we call it, Janie? They're in our sort of tech advisory group. Is
Yes.
that what we
Yes.
call it? And so they're every, several months we're checking in with them and so on. But it won't be till we finish with all, well, I think with all three of the integrated system packages, then we'll then hand off to them. And as far as like where they're going to test it in the country, I don't think they've made commitments. I think they made commitments that they will, they will test this stuff and sprinkle it around, but I don't think anything too hard and fast. But that's going to be not for probably another year and a half. Or when,
I think
once
as I understand it, for the tenant fit out package, when it's done with the FlexLab validation, we'll get into field evaluations and CBRE. I think they're currently shopping around among their portfolios some spots where this could be implemented.
So they won't wait till we get
I don't think they'll wait till all three will be done because for each FlexLab test, when we're talking about the RTU swap out, that's a big test that's going to take some time. We don't want to hang the whole 3-year project up for that to happen. So yeah.
I think the answer, Larry, is that the goal has been, because we found in the interviews that there was variation across the country. If we talked to somebody in Ohio, we got one set of answers. If we talked to somebody in Silicon Valley, we got a completely different set of answers. It's almost like even though we were presenting the same information, they were hearing it differently because their experience of commercial buildings is different. And so that told us that we need to go out, and when we're demonstrating this in actual buildings, we really would like to demonstrate in cold weather, warm weather, dry, humid, as much variety as we could. So that's the goal going in. Now, the reality is we've seen plenty of projects that are torpedoed because we can't get buildings to participate. because that's a big commitment for folks. So that's why we're working with CBRE ahead of time to let them know we're looking for these kind of buildings. But the reality is it's going to be the buildings that present and that are in that stage of something related to a tenant fit-out program. And that's the third year of the program.
So when you do these, the run through the FlexLab and you come up with some idea of what the savings is, how do you talk to these people about the possible variation or your confidence in your numbers? Because I'm really sick of just seeing averages, not from you, but from everyone, where I never see an estimate of variance or some sort of probabilities.
That plot before, I think, showed like median and then upper and lower bounds on 95% confidence interval or something like that. So we try to like run robust statistics on our results rather than just come up with one average.
Communicating it to the client?
Communicating it to the client, I don't know, Phil, if you have more insight into that. Again, I'm a little bit more like the worker bee down in the test cells, like I don't communicate it to the... Yeah, yeah, exactly. The human element.
Now, we're all about sensitivity analyses at LBL in every sense of the word. But, the great thing is there's some really progressive energy people at CBRE who've expressed interest in this and who get things like these uncertainty bounds and so on. But that'll be a challenge too, how to say, well, it was great here in Berkeley, on, in the spring it saved this much. And we have to find a way to communicate that. And also, that's not only sort of accurate, but intelligible. Yes, risk communication, yeah. Exactly. But that's going to be one of the challenges going forward, and I don't think we grappled with it much, but we will. Yeah. That's a great question. Yeah.
Given the scope of what you're doing, both the packaging side and also trying to develop the value propositions, and buildings are commodities after all, and treated as such, especially in the commercial sector. And, you're familiar with the 330-300 principle?
No. $3 per square foot for the energy, 30 for the space, and 300 for the people?
Yes.
Yeah.
And how that factors in. And there's this whole JLL is really at the forefront of it, of pushing the notion that occupant comfort and productivity are really, really important. And the kind of things you're doing with these packages fundamentally is improving occupant comfort as well as energy. And so what's really the best selling opportunity?
Yeah, I come back in 1 or 2 years, and we're going to be at that stage where we're going to be doing these, pitches to the, to CBRE and then to the wider, commercial, to the JLLs, et cetera. But I think one thing we really, learned from the interviews was that these, broadly speaking, these non-energy benefits or the asset value or these things can be huge drivers. So when we pitch this stuff, to this gentleman's remark too, we need to not just pitch that, range of savings, but also talk about these other benefits that will speak to the $300 per square foot versus the $3. Yeah.
Inherently, the challenge there is that we can measure the energy parameters pretty straightforwardly, and we can assign dollar values to those. These more qualitative non-energy benefits have been very hard to assign dollar values to. So even if we know that the human costs $300 a square foot or whatever, knowing how much benefit they get from the systems is still, we look at, again, a lot of the interior parameters around comfort, and I didn't actually get a chance to show a picture, but we have these thermal comfort stations that do mean radiant temperature, air velocity, and then we'll do relative humidity, and you can calculate, the likelihood that a person in that space will be comfortable as a result. And that's when these things like using a ceiling fan and a cooling setback, you need to be able to validate that a person would still be comfortable in that scenario. or maybe with the automated shades, if they're more comfortable than in the base case, then yeah, it'd be great to assign a dollar value to it. But it's sort of hand wavy at this point compared to kilowatt hours saved, which is, you know, it's kind of like a solid bottom line number.
One of the things that Steve Taylor has been looking at is, you know, different ways of delivering comfort and versus energy with the hash rate 36.
Okay. Yeah.
What we may think an occupant wants, they're finding isn't necessary. So they're doing pulses of air, for example, for ventilation.
So they're
Okay.
playing with the ASHRAE comfort zone, you're saying? And
Yeah.
They're finding that occupants don't know the difference, and it's perfectly fine.
Yeah, actually, intermittent ventilation like that is one of the measures that we looked at in our original panoply, and when we were kind of down selecting, for whatever reason, that one, it's sort of in its infancy in terms of being adopted by practitioners in the field, but we certainly looked at that for that reason. You know, you can choose, and actually Ian was talking about this earlier in the day, but you can choose not to ventilate during, you know, peak period when energy is the most important, and then ventilate kind of before and after. And as you said, if the occupant doesn't know the difference, or better yet, maybe they prefer it for whatever reason that way, then you save a lot of energy and kind of everybody wins. But if ASHRAE hasn't been putting that strategy forward, you know, in the past decades, then it's kind of hard to get folks down at the kind of the building level to participate in that type of like an efficiency measure. So, yeah.